Oh, die kan je stellen.
Nee, het is draaien.
Oh,
Wordt ook niet kunnen.
nee. Oh.
Hij wordt zo laag.
So hello everyone, welcome to the first video in a short series where I show you my live steam locomotives in detail. Today's video is all about the first engine in my collection. This is an example of the Roundhouse Engineering Basic series locomotives that they call Bertie. I bought the loco in 2018. From the factory, it was finished in the standard roundhouse colour of FR Victoria Maroon and was manual control. Like all my engines, the Bertie is named after a family member. As you can see, it's named Ernest and is my tribute to one of my granddads. All of his working life, he was one of the thousands who helped construct some of the finest steam locomotives in Great Britain at Crewe Works. When I was at primary school age, I used to stay with my grandparents most weekends, and I had a fantastic relationship with my granddad Ernie, and I miss him very much. So let's take a closer look at the engine, starting with the exterior. Ernest has an LMS yellow lining scheme. And that's a reference to the time my granddad worked at Crewe Works for the LMS. And with a black border, and you can see it quite clearly on the cab there. It's got a rear bunker in the same paint scheme, and the paintwork continues in the cab when it's got a mixture of half and half cream and black. While mentioning the cab, there are range strips added to the roof, cab step overlays fitted, and there's a pressure gauge. There are etched buffer beams fitted front and back, and the backs are painted black. And the original cheese head screws have been replaced by bolts. That looks much more realistic. Now I'll put up a roundhouse photograph of a Bertie in Victoria Maroon as it comes from the factory, and I find the original bare metal wheels and cylinders to be very unprototypical. So the wheels and the eccentric rod, which is this guy here, were painted black, and I've fitted painted cylinder covers. There's a lubricator set, 2 on each side, sandbox, 1 on each side, and I hope you can see it in there. There's spring details in there fitted around the engine, and to finish it off we have a brass handrail going around the saddle tank with an integrated lamp iron there, and a brass chimney cap, and of course the Ernest nameplate. Overall, I'm very pleased with the result, and when I steam the engine at the club, I often get compliments from the public about how it looks. So let's have a look at the technical details of the locomotive. What are all the bits? What do they do, and how do you use them? I'm going to apologise up front for those that are already experienced with live steam engines, but looking at some of the comments in my videos, there's a number of viewers that are either just starting out or thinking about taking the plunge into live steam. So this section of the video might seem to some as if I'm teaching them to suck eggs, but that's the way it is. Anyway, let's get started. So as you can see, this is a 040 wheel configuration engine. That means, besides being the most simple of wheel arrangements, it means the engine can handle tight radius curves of track. Something that for folks that maybe do not have a lot of room in the garden or in the house for large radius curves will appreciate. Okay, let's take a look at the cylinders. This is the cylinder assembly. And in the lower half of the cylinder assembly, you've got the steam chest. This is where the steam comes in. And via this rod here and all the other rods here, that drives, provides movement to drive the wheels. In the upper section here, this rod is attached to a slide valve in this cylinder, and the slide valve, that provides the timing for when and where the high pressure steam enters the steam cylinder. Now this valve, sliding valve, that's driven via this rod here, and that goes right to the back but inside of the rear driving wheels, and there is an eccentric cam fitted to those rear driving wheels, and that provides the oscillating movement for the valve gear. So if I just move the wheels forward, you can see that cam, the eccentric cam on the inside of the wheels, and that provides the movement. And you can see there's the eccentric rod. There, you can just see him through that hole in the chassis, and you see it's moving backwards and forwards. Okay, the boiler on this locomotive goes from roughly here underneath this saddle tank bodywork all the way back to perhaps 1.5 inches. Sorry, we're metric. Perhaps 3-4 centimeters into the cab. The water in that boiler has been the capacity of that boiler, perhaps I should say, has been figured out by Roundhouse so that in combination with the amount of fuel on board the locomotive, that it's always the fuel that gets finished first. There's always enough water in the boiler so that the boiler doesn't run dry, and that's obviously very important, otherwise you can get serious problems. In the boiler, through the middle of the boiler, there's like a tube, a flue, where the burner fits in, and we'll take a look at that perhaps a little later on. The boiler is filled by taking off this dome, and here this is actually the safety valve, but it actually doubles as where you fill the boiler. So you remove that, and then you can fill the boiler according to the instructions of Roundhouse. So what that basically means is you fill it with the correct sort of water until it's right to the top, and then you remove 30 milliliters of water, so there's a little bit of room between the top of the water level in the boiler and the casing of the boiler where steam can build up. Okay, here's a close-up of the safety valve. And the safety valve is set up so that steam blows off just before the 40 pounds per square inch. I think it starts at something like 32 or something like that. You'll have to have a look on the Roundhouse website. And then at 40 psi, when it goes above 40 psi, it blows completely off. And then what happens is this middle pin drops, and then the steam pressure comes out. However, inside the safety valve, there's a gubbins with a spring and everything, and this inner section, if you look at it, this inner section, it's sort of screwed into this outer casing. And what they do at the factory, you can just about see it on the side here. Once they've calibrated the safety valve, they give it a whack with a punch, and that should ensure that the safety valve, that this inner mechanism doesn't move. Now, because you're constantly in the use of a locomotive, you're undoing this to fill the tank up with water, it can happen that over time, and I have experienced this, that let's call it the locking mechanism that they've used by whacking it with a punch doesn't actually work, and this inner section can rotate, and then you've got problems, because then what you get a safety valve with a different blowing off pressure than that recommended by the factory. What I've done, it's set up at 40 psi, and then what I've done, besides giving it an extra whack, I've actually marked it, the outer edge of the casing and the adjustable part of the safety valve. I've actually marked them so I can see in an instant if for some reason or another the safety valve setting has worked loose. Okay, we just moved over to the cab now, and I'll try to point this out. Here's the rear of the boiler, and what I want to look at is this chappy here. Let me see if I can get that. This guy here, this is the burner. This assembly here is the burner that goes into the back of the boiler. This is the gas line that comes in from the gas reservoir. The gas tank is actually in the right hand side of the cab here, and you fill it through a hole in the roof with a special adapter. And this is your gas regulator valve here. So you screw it anti-clockwise to open and clockwise to shut it. Okay, back on the left hand side, I'd like to point out this cap, and this is the cap to a cylinder that's fitted in here, and that is the steam lubricator, and that is for lubricating the internal parts of the steam line. So the cylinders, the valve chest, those components. And it works, it's got quite an ingenious system. Just let me take the cap off a second. Okay, you can just about see in that lubricator, there's a pipe that goes through, and there's a tiny hole in the top of it. And what happens is steam comes through that pipe, and you fill, before starting your engine, you fill this container up with special steam oil so that it's just above the level of that pipe. So what happens is when the cap's on and pressure's built up and steam is being generated, a tiny amount of steam is leaked into that cylinder. And what happens is the water from that steam condenses, forcing the oil that's in there up and through that tiny hole as well, and then that oil gets moved, transported with the steam to the rest of the internal parts. And it's quite an ingenious system, really. So as the locomotive is running, more steam gets generated in this cylinder, it condenses to water underneath, steam oil gets forced automatically into the line, the steam line. Okay, so I've just put the loco on its side to show you this component here, and this is an extension of the lubricator, and this is a drain plug for the lubricator. So the idea is that at the end of each session you loosen this drain plug. Don't have to take it all the way out, just have to loosen it a bit, and then the excess water will just drain out. And in my George build series, I showed that process in one of the videos after the steam up, the first steam up.